Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem modified game of name. So this is a medium level question and it's the problem of the day on Geeks for Geeks today. So the topic tags of this question are bit magic, game theory and data structures. So let us go to the question now. You are given an array of n elements. There are two players, player 1 and player 2. A player can choose any of the element from an array and remove it. So there is no perspective of the order. You can choose any element. If the bitwise XOR of all the remaining elements equals 0 after the removal of the selected element, then that player loses. So let us assume you are player 1 and I'm player 2. You have selected an element, you have picked an element and you have removed it from the array. Then the XOR of the remaining elements, if the XOR of the remaining elements turned out to be 0, then you lost the game and I won the game. Okay, so please make sure you're getting a note of it. So find out the winner of player 1 starts a game and they both play their best. So what do they mean by when they say they both play their best? That means they'll be choosing the most optimal choice or option available. So they'll be looking like to make sure the opponent loses or there is no room for opponent to win the game. So they'll be choosing a most optimal available choices out of all the choices. Okay, so these are some examples given, example 1 and example 2. Example 2 is needed to be analyzed here itself. So let us see that. So a is given to be 3 comma 3. What is the XOR of this a right now? It is 0 because 3 XOR 3 is equal to 0. Even number of elements of the same element, that is equal to 0, right? The XOR of even number of elements of the same element, right? So 3 XOR 3 actually equal to 0. So before the player 1 starts something, the array turned out to be 0. The XOR of the elements of the array turned out to be 0. So in that case, player 1 wins. Okay, so to be honest, we can even simplify this question in other ways. So let us assume you have done some operation, and for me the available choice of array as all the elements. Okay, after you have removed something, now you have given me an updated array. The XOR of all the elements of this updated array turned out to be 0. Then I am then you lost it, I won it. Okay, so before I start, if the elements of the array, okay, if the elements of the XOR of all the elements of the array turned out to be 0, then I'm the winner. Before I start, if it is 0, then I'm the winner. Okay, so you can even understand the question in that terms. So that is the reason player one wins here, because before player 1 can choose anything or do anything, the XOR of the array turned out to be 0. So player 1 won. Okay, so let us assume after doing some modification, he has given that array to player 2, and that modified array, the XOR of all the elements turned out to be 0. Then player 2 wins, because before player 2 can do anything, the array that he has got, the XOR of all the elements turned out to be 0. So player 2 wins. Okay, you can even understand the question in that frame. So what is the expected time complexity? O of n, and space complexity is O of 1. This is the most optimal possible, and we'll even see that particular solution itself. So now let us go through the example. So here the example says optimal removal of values are 3, 2, 3 sequentially. So first, if you can just remove 3, the player 1 removes 3. So once he removes 3, what is the available array? It can be 3, 2. Okay, let us assume he's removing this because there is no perspective of the order here. So 3 XOR 2 is what we'll be having. Is 3 XOR 2 0? No, it's not. So once again, now the player 2 will be removing 2. So once he removes 2, what is the new array that will be there? 3. And now on this, player 1 needs to operate. Okay, so if player 1 tries to remove this, what is the XOR of the remaining elements? That is 0, right? So because it's an empty array, so once he gets an empty array, now player 2 need not do anything. He's already got an array such that the XOR of all the elements in that array is 0. So ultimately player 2 wins, right? So that's the reason output is 2. I hope you people are understanding. Before player 2 can do anything, he has got an empty array. So empty array in this sense, XOR of all the elements that are present means no element is present, so XOR is 0. So player 2 wins in this case, right? So I hope you people have understood. So before we going to proceed with the approach, I would like to highlight a point related to these type of problems. So where most optimal thing is given, or like if player 1 starts, what happens to the best, what happens at the end of the day, like who is going to win. So all these things can be generalized. Okay, all these type of problems can be generalized to a specific pattern. So if you could identify a pattern after taking several test cases, like in my case, I was not even able to solve this question for the first 1 hour. Okay, I woke up at 5 a.m. today and I solved from 5 to 6, but I was not able to solve this question because I was thinking like I was thinking of many methods to actually solve this, because the most optimal method that's mentioned in the question, that confused me a lot. So I was like not able to figure out the best way. So what I did is I took several examples. Okay, I took nearly 15 to 20 examples, very basic examples, not big numbers, very basic examples I've taken, and I've thought of identifying some pattern. So what if n equal to even, what if n equal to odd, where n is the size of the elements of the array, right? So because it's the same thing, because it's the same thing that's mentioned in the question. What is he mentioning? What's the question mentioned? So first player 1 starts, and then player 2 starts, and the player 1 starts, and the player 2 starts. It goes on like this. So at the end of the day, it's just like even number of elements and odd number of elements. Let us assume player 1 starts with even number of elements. What is the end result? Let us assume player 1 starts with odd number of elements. What is the end result? So I thought of generalizing like that, and it completely worked. Okay, it completely worked. So for that reason, I even cross-checked with various other articles, and I finally understood that yes, there is some relation. And before even doing that, what is the other thing that we need can check before itself? So in the example 2, if you can see this array that has been given, initial array that has been given, the XOR of all the elements is 0 initially. So we'll be putting that condition for sure. We'll be checking that first condition for sure. What if the XOR of all the elements right now at the beginning itself is if it's 0, then player 1 wins. Okay, so we'll be checking that condition anyways. But after checking that condition, if the XOR of all the elements of the array is not 0, then we need to do some calculation. So what is that calculation? For that, I have tried to generalize the things. What if the size of the element, size of the array is even? So what would be the end result? What if the size of the element array is odd? What would be the end result? So this is how I calculated things, and it completely worked after checking with the other articles and etc. So what is the thing is, so first condition is check XOR of all elements. Okay, XOR of all elements. If it is 0, okay, if it is 0, then player 1 wins. Isn't it? Player 1 wins, because before player 1 can do anything, the XOR of all elements is 0. So player 1 wins in this case. Let us assume it is not equal to 0. Okay, not equal to 0. Now you need to do some further calculation. So that calculation turned out to be if n equal to even, okay, n equal to even, or n equal to odd. Okay, n equal to even or n equal to odd. So what happens in this case if n equal to even? So let us take something like this. Okay, a, b, c, d, e, f. Let us assume these are the elements in the given array. N equal to even. So in this case, n equal to 6. Okay, 6 elements. So let us take a simple example. Do not complicate yourself with a lot of things. Okay, so n equal to even. Now what I need to say is I need to come to a conclusion. If n equal to even, who is going to win? If n equal to odd, who is going to win? So I'm saying that if n equal to even, I'll say this player 1 wins. Okay, n equal to even, then player 1 wins. But how am I saying that? I need to justify my explanation, right? I need to justify the result that I'm trying to put out. So we have seen that it is not 0. So this condition is checked here itself. The XOR of all elements is not equal to 0. So if it is equal to 0, then player 1 wins for sure. If it is equal to 0, the beginning it's equal to 0, then player 1 wins for sure. But now we are coming to a case where the XOR of all elements is not equal to 0. But still I'm saying that player 1 wins. How is that possible? So I'm saying that I'll pick up some element. Let us assume I'm going to pick up this element. Now the XOR of all the other elements, is not equal to 0. XOR of all other elements is not equal to 0. If it is equal to 0, then I'm gone. Then player 1 is not going to win, isn't it? If it is equal to 0, then player 1 is not going to win. So the very first condition itself, it should be like I'm going to pick up some element. Okay, I'm going to pick up some element, so that this XOR of all other elements is not equal to 0. And I'm saying that this is valid for any value of n, like any even value of n. Okay, either it may be n equal to 3, n equal to 4, or n equal to 6, or n equal to 2, whatever it is, provided that the XOR of all the elements at the beginning itself is not equal to 0, then player 1 can choose any of the options. So how am I telling it? So let us understand that particular point. Okay, so let us assume, okay, what am I saying? The very first thing is how did we come to this particular point? A XOR, B XOR, C XOR, D XOR, E XOR, F is not equal to 0. This is the particular basis, right? On this particular basis, we have come to these conditions. If it is equal to 0 in the first point only, it's done. In the year itself, it's done. The player 1 is going to win. But we have come to a situation where all XOR of all the elements is not equal to 0. Now, if you are trying to pick A, okay, let us assume you are trying to pick the first element. So let us assume this whole thing, okay, I'm assuming it to be some yes. Okay, so you need to prove that if I'm choosing some A, okay, XOR A, okay, XOR A is equal to 0. You're in a position like you're arguing that player 1 cannot win. You're saying that player 1 cannot win. You're saying that player 1 has no best move. You'll eventually get, after choosing some element, you will eventually fall in a trap where all the XOR of all the elements would be 0. So that's what you're saying. But I'm saying that it's not like that. It's always possible for player 1 to choose some element. So that's what I'm saying. So for your argument, you're saying that XOR A equal to 0. Okay, and let us assume you're trying to pick B. So in that case also you're saying XOR B equal to 0. In that case, if you're picking C, XOR C equal to 0. What am I writing this? So what is XOR A? XOR A in the sense B XOR, C XOR, D XOR, E XOR, F. Because when you're putting XOR A, So yes, this is whole yes. So when you write XOR A and A gets cancelled because even number of A's. What are the remaining things there? This is the remaining thing that's there. That is what you're trying to calculate, right? So if I'm saying that I'll be picking A, the XOR of remaining elements must be equal to 0 according to you. You wanted to say that player 1 has no valid move. So you're saying that if I pick A, then the XOR of remaining elements would be 0. So that's what you're saying. So that is what I'm representing, XOR A to be equal to 0, right? That's what I'm representing. So I'll just remove this. So I hope you're understanding. When I pick A, the result, the other result means the XOR of all the other elements can be represented as XOR A, right? So I'll even erase this. Okay. Okay, fine. I'll just, okay. This is A, okay. So now B is done, C is done. Now let us assume I'm picking D, and then also you're saying that XOR D would be equal to 0, XOR E could be 0, XOR F equal to 0. So you're saying that there is no possible move. Either you pick A or pick B or pick C or pick D or pick E or pick F. You'll finally end up with getting with all the elements. The XOR of all the other remaining elements is 0. That's what you're claiming. I'm saying that no, that's not possible. And for that fact, I'm trying to prove. So these are the statements that you're telling. You are telling. Okay, these are the statements that you are telling. Now let us XOR all these equations. Okay, XOR A, XOR XOR B, XOR SOR Z, XOR SOR D, XOR SOR E, XOR SOR F. Okay, let us assume I have done all these things. So even number of S's would be there because we are taking n to be 6. So we'll be getting even number. So S gets cancelled. Okay, all the even numbers will eventually give you 0. Now what are the remaining things that we are left out with? A's or B's or C's or D's or E's or F, right? And is this equal to 0? Is this equal to 0? No, it is not equal to 0 because that is what we have taken up, right? That is the condition on which we have come to this second condition. If this is equal to 0, in the first case only the matter is over. The game is over. The first case only player 1 is going to win. But we know that A's or B's or C's or D's or E's or F not equal to 0. So if you're telling all this equal to 0, then the right hand side, once you do XOR of all this must also be equal to 0. But are we getting 0? No, A's or B's or C's or D's or E's or F is not equal to 0. It's not equal to 0. Fine. So whatever the thing that you are saying, that's not going to happen. That player 1, you are saying that player 1 has no way to win. I'm saying that no, it's not possible. Player 1 has always has a way to pick up some element. Okay, pick up some element if it's an even number of elements, and provided that this XOR of all the elements is not equal to 0. So that is where we have completed come to a conclusion that yes, player 1 is going to have one move at least. Okay, player 1 is going to can take at least one element of them, so that the XOR of all the other remaining elements is not equal to 0. Okay, I hope you people have understood. The way we proved is very fantastic. So I hope you people have understood this. If not, just watch this video once again. Like just watch this part once again. Okay, so once we say that yes, player 1 can pick an element such a way that the XOR of all the elements, okay, the XOR of all the other elements is not equal to 0. Okay, so we can pick like that. So what is the worst case possible? Let us assume I'm taking an array like this, A, B, C, 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 C. Okay, this is one of the worst case possible, right? Because I've told that player 1 can choose an option since the XOR of all the other elements is not equal to 0. So this is actually equal to 0. The XOR of all these is actually equal to 0. Now I need to make sure these two, like what is the condition I'm saying? A's or B's or C's or C's or C's or must not be equal to 0, right? This must be there initially. So if this is not equal to 0, that means A's or B. Okay, A's or B should not be equal to 0 because this is actually equal to 0. So this must not be equal to 0. If this must not be equal to 0 in the sense A must not be equal to B or A must not be equal to 0. So either both of them must not be equal to 0 or one of them must not be equal to 0, and A should not be equal to B. In these cases, I can eventually pick one element such that the XOR of all the other elements is not equal to 0. So let us assume, okay, so I'll just remove this. Okay, I'll just remove this, and now I'll be writing the things. Player 1, after player 1 picks, let us assume player 1 is going to pick this. So what is the updated array now? So B, C, 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 C. Okay, now what does player 2? If player 2 takes this particular B, the XOR of all the elements would be 0, isn't it? C's or C's or C's or C would be 0. Then player 2 will pick that. No, we will not be picking that. He'll be picking some C here. Okay, he'll be picking some C. This or the first one, second one, third one. Let us assume I'm picking this C. So if I pick that, now player 2, after player 2 taking removing the array, removing the element, what are the remaining this? B, C, C, C. Now what will player 1 do? Player 1 will do such a move so that the other elements will not be equal to 0. XOR of other elements is not equal to 0. So he'll be choosing the best move. What is the best move? So instead of taking C, let us assume he's taking this C. So if he's taking this C, then Z's or Z would be equal to 0. And if in case B is equal to 0, then Z's or equal to C, 0 or 0 would be 0. So that is the reason you'll not be taking it. So he'll be taking such an option. Okay, he'll be choosing such an option such that player one, player two eventually win. Player two eventually loses, right? Now it's a choice for player one. So player two already done, and now this is the updated array. So now player one will be choosing this particular element B. Let us assume is going to, okay, I'll be using yellow arrow, yellow circle itself. He'll be choosing this. After doing this, what is the after taking this player one move, what is the updated array now? So it would be C C C. So now player two has to do something. Now player two, if he chooses this or this or this, eventually it will become, the array will be like this, C is or C, and this is actually equal to 0, right? So whatever the thing it is, whatever the choice player 2 is going to have, you'll eventually end up falling in a trap that after removal of any element, the XOR of all the other elements would be equal to 0, right? So this is the worst case possible. This is the worst case possible for player 1 to win, because we have constrained player 1 to win, and in the worst case itself is winning. So in the best case he'll definitely win. Okay, why are we calling this as the worst case? Because we have only two options for him to pick, either A or B. So we have confined his position. So we have limited his chances of winning. So that is the reason I'm saying this is the worst case. In the worst case itself is winning, so in the best case he'll definitely win. Okay, I hope you people are understanding. I'm putting it in layman terms for you people to understand. Okay, so when it is an even, if n equal to even, then definitely, if n equal to even, definitely player 1 wins. Okay, player 1 wins. If n equal to even, player 1 wins. So I hope you people have understood. So first thing what we have done is we have taken some examples. Okay, we have taken few examples, like we have taken the worst case, and before that we are trying to prove that if n equal to even, definitely player 1 will have some choice to take. Okay, so that we have proven. If n equal to even, and provided the XOR of all the elements beginning is not equal to 0, then player 1 will definitely have one choice to pick. So such that the XOR of all the other elements is not equal to 0. So after picking that element, now you need to analyze for the player 2. Player 2 will pick some of the other element. Again, player 1 again picks some other element. So that we have taken the worst case and we have tried to solve it, and we have finally come to a conclusion that player 1 is going to win whatever the thing it is. Like if n equal to even, whatever the value it is, 2 or 4 or 6 or 8, whatever it is, if n equal to even, then player 1 is going to win. Okay, so I hope you people have understood. Now what about n equal to odd? Same thing happens, isn't it? So we have proved that for n equal to even, player 1 is going to win. Player 1 wins, right? Player 1 wins. What if n equal to odd? So player 2 wins, isn't it? Very obvious. Why is player 2 losing here? In the first case? Because player 1 is taking the even positions and player 2 is taking the odd positions, isn't it? So let us assume n equal to 6. Okay, n equal to 6 in the sense number of elements equal to 6. So first player 1 takes the chance. Okay, let us assume in all the cases at any point of time, the XOR of all the elements is not turning out to be 0. Okay, at any point of time, the XOR of elements is not turning out to be 0. Like let us take an example like this: A, B, C, D, E, F. Okay, so whatever you choose first, let us assume you and I are playing and you are player 1. After you choose A, the XOR of other elements is not equal to 0. Either you choose B, the XOR of elements is not equal to 0. Now again I'll be taking some of the other element. Again the XOR of the elements is not equal to 0. So we are taking like that. Okay, we are taking such an instances where after picking whatever the thing it is, the XOR of other elements is not turning out to be 0. Whatever it is, whatever position it is. So in that case, finally what happens is, so we'll be getting an empty array, and whoever gets that empty array is going to win, isn't it? So n equal to 6, player 1 is going to take, and then what will be there? And then 5 elements would be there. This is initial. Okay, initial. So after which n equal to 5, player 2, n equal to 4, player 3, n equal to 3. Sorry, so I'll just write this. This is 2. So this is 1, and this is 2. So what do I mean by this writing player 1 and player 2? N equal to 6 will be played by player 1. When there are 6 elements, player 1 is going to play. When there are 5 elements, player 2 is going to play. When there are 4 elements, player 1 is going to play. When there are 3 elements, player 2 is going to play. And now again come to this, n equal to 2 elements. So when n equal to 2 elements, player 1 is going to play. Okay, so when n equal to 1, so player 2 is going to play. So I'll just write this perfectly. So, and when n equal to 0, there are no elements. So who is going to play now? Player 1. So that's the reason player 1 is the winner. So player 1 is the winner. So because once player 1 is going to do something, there are no elements in the array, so there's nothing to deal with it. So that's the reason player 1 is going to win eventually. So this is the case when whatever choice you're going to take, the XOR of all the remaining elements is not equal to 0. So that is where this is. So this is the best possible thing. So why is this player 1 is winning? Because player 1 is taking the even position. Okay, player 1 is taking the even position. Similarly, when n equal to odd, so when n equal to odd, player 1 first starts, right? Player 1 first starts, because in the question it's been clearly mentioned, player 1 starts. So when player 1 starts, he's going to take the odd position, and player 2 going to take the even position, isn't it? Player 2 going to take the even position. That's the reason player 2 is going to win eventually at the end of the day. He is going to win. He is going to be is going to win. He's going to win. Player 2 is going to win. Isn't it? I hope you people have understood. So the same concept, we are generalizing it. So if n equal to 1, player 1 is going to win, because n equal to 1, player 1 is going to take the even number of even positions. But in n equal to 2, player 2 wins, because n equal to 2, n equal to odd, player 2 wins, because when n equal to odd, the very first case is going to be taken by player 1. In both the cases, player 1 is going to take. So player 1 is going to take odd number of cases, and then player 2 will be coming to the even positions. So that's the reason player 2 wins. Okay, I hope you people understood. The same logic you can even apply to this particular thing as well. Okay, so we have covered all aspects possible. So I'll just remove this. So in this case, play n equal to even, player 1, in n equal to odd, player 2, right? So I hope you people have understood. So very basic thing, to be honest. Just like you need to understand the concept here. Like whenever there is a question like these type of things, like player 1 chooses, player 2 chooses, something like that, there's always a place for this generalization. Fine, if you can just generalize, try to generalize by taking several examples, working on several examples, you can get a pattern and you can generalize this, and you can just correlate with the things, whatever the other things that are there. Here we have correlated with two things. First one, we check if we can have an optimal move possible for player A. Yes, we have taken two cases. Worst case, where we have limited the number of options available for player 1 to choose, and we have taken the best case. So whatever the option you're going to choose, the XOR of all the remaining elements will be non-zero. So at any stage of position, either it's n equal to 6, 5, 4, 3, 2, 1. So we have taken that two types of generalizations we have taken, and finally we got to know that at whatever it is, a player 1 is going to win if it is an even number of elements. Same thing will be applying to this odd as well. You'll be able to find that player 2 is going to win. Okay, so I hope you people have understood. Let us frame the code now. So first, int answer equal to 0. Okay, int answer equal to 0. Now we'll be taking this with we'll be taking XOR with each and every element. So int I equal to 0, I less than n, I plus plus. So answer XOR a of I. Okay, so once we did this, if this turned out to be 0, okay, if this XOR turned out to be 0, or the value is actually the size of the element is size of the array is actually even, so in both of these cases you can return 1 as the winner or 2 would be the winner, right? So we can just compile and run for your reference and we can check it, and yes, it's going to work. Yes, and we'll even submit now. So I hope you people have understood the logic. So if the XOR of all the elements, okay, is 0, then it's definitely player 1 is going to win. Or in case if the number of elements, if that is even, then also player 1 is going to win, provided that the XOR is not equal to 0. Okay, once we have come that, then if both of these are not the case, like if answer is not equal to 0, like the XOR is not equal to 0, and even the number of elements is not equal to 1, sorry, even, then player 2 is going to win for sure. Okay, so I hope you people have understood. If there are any doubts, please feel free to comment in the comment section. I'll revert back to you with your answers. And for your reference, codes in C++, Java, Python are there in the description. Please go through them. And time complexity is pretty simple. It's O of n, space is O of n, because we are not using any extra space here. Okay, so that's it guys. Thank you for watching. Stay tuned.